A normal car engine spends more time not making power than making it. 3 out of 4 strokes are just set up, only one actually generates power. The Wankel Rotary solved that problem in 1957. It runs all 4 strokes simultaneously with 0 pistons and 0 valves. Inside a chamber that the engineering world said was impossible to seal, Mazda was the only major car company on earth willing to bet their future on it. And for decades, it made their cars some of the best handling machines ever built. Here's how it actually works. A conventional piston engine is violent by design. A piston hammers up and down thousands of times per minute, reversing direction completely each cycle. It only produces power on that single combustion stroke. That reversal creates vibration, it creates heat, it creates mechanical stress. Engineers have spent 150 years trying to manage those trade-offs. Felix Wankel had a different idea. What if nothing reversed direction? What if every moving part rotated continuously in one direction? The problem was geometry. To do that, you need a chamber that can expand and contract as a rotor spins. But you also need that rotor to maintain near perfect contact with the chamber walls at all times. Or you lose compression, you lose combustion, you lose everything. The shape that makes this possible is called an epitrochoid. It's the path traced by a point on a circle rolling around the outside of another circle. The result looks like a rounded triangle with slightly bulging sides, and a 3-pointed rotor fits inside it almost perfectly. As the rotor turns, its 3 tips maintain constant contact with the chamber walls. And because the rotor is triangular, it creates 3 separate volumes, 3 sealed chambers that continuously change size as the rotor moves. One chamber is expanding, one is compressing, one is firing, all at the same time. The engine never stops its power cycle to reset, it just keeps going. Here's the part most people get wrong. The rotor doesn't spin around a fixed center point, it orbits. The rotor sits on an eccentric shaft, a crankshaft with an offset lobe. As the rotor moves, it traces a path where its center is always orbiting the shaft center. To keep this synchronized, a fixed stationary gear on the engine casing meshes with an internal gear inside the rotor. This creates a precise 3:1 mechanical ratio. For every full rotation of the triangular rotor, the output shaft spins exactly 3 times. This offset creates the changing chamber volumes you need. As the rotor moves into one position, a chamber opens up, intake fuel and air are drawn in. As it continues rotating, that same chamber shrinks, spark plugs fire, and the Wankel uses too, because the combustion chamber is so elongated that a single plug can't reliably ignite the full charge. The expanding gas pushes the rotor, continuing its rotation. Then that chamber opens to the exhaust port and burned gases escape. 3 tips, 3 chambers, 3 complete power cycles per rotor revolution. A 2-rotor setup, like in Mazda's RX-7, delivers 2 power pulses per output shaft revolution, exactly like a 4-cylinder piston engine. But here's the secret. A piston engine's power stroke lasts for just 180 degrees of rotation. A rotary's power stroke lasts for 270 degrees. The power pulses literally overlap. The engine is essentially delivering continuous power because the engine never has a dead spot between 2 power strokes. It can rev far beyond what any piston engine can sustain. This is why rotary engines scream. The RX-7's 1.3-liter twin rotor produced 255 horsepower in its final form. That's 196 horsepower per liter. Numbers you would expect from a full racing engine, not a street car. But the Wankel's biggest weakness comes from the same place as its greatest strength, those rotor tips. The apex seals, thin strips of metal at each rotor tip, have to maintain a gas-tight seal against the housing wall at thousands of RPM. While surviving extreme temperature swings, every single rotation, piston rings have one job in one direction. Apex seals have to do it continuously around a changing, curved surface. Worse, a piston engine cools slightly during the intake stroke. In a Wankel, the combustion zone stays permanently hot, while the intake zone stays permanently cold. This massive thermal difference warps the metal housing, making a tight seal even harder to maintain. Early Wankel engines burned through apex seals within 50,000 miles. Mazda spent years reformulating the seals, the housing surface coating, and the lubrication strategy, injecting oil directly into the intake to keep the seals from dry running. The other trade-off is fuel consumption. Because the combustion chamber is long and thin, some fuel-air mixture always escapes past the seals before fully burning. The Wankel runs rich by necessity. The RX-7 was not a car you bought for economy. Mazda never fully abandoned it. In 2023, they bought the Rotary back, not as a primary engine, but as a range extender generator in the MX-30 hybrid. A single rotor unit running at a fixed, efficient RPM, doing exactly what the Wankel does best, spinning continuously, smoothly, with no vibration. A single rotor, no pistons, no valves, 255 horsepower from 1.3 liters. Felix Wankel first solved this problem in 1957. Mazda is still using it in 2023. That's not nostalgia. That's engineering that actually works.